I'm going to do a bit of an introductory session. I'm sure a lot of you know the background, but there might be some people who don't know the background. But I'm going to talk about how greenhouse gases are accounted for. And really, it's around who's asking the question or what you want the answer for. So there's different methods, and sometimes it's used in not the greatest ways. So, for example, you can use all sorts of metrics when you want to start describing something. There's a plethora of memes that talk about things like this. Here's another metric, driving 10 Ks compared to 300 grams of beef. There's lots of those sorts of things. Are they right? Are they wrong? Are they incomplete? Are they overstating, understating? And I always remember John Young, who's an economic modeller, saying that people always ask him for a simple answer. And he said, I can give you one, but it'd be wrong because it's actually a complex thing. So that's the world we're stuck in. But I'll try and give you a bit of background about how things are calculated and where you tend to use different calculations. Oh, there's another one there, which I thought was another interesting one. Atmospheric carbon rise by 50%, and that in itself is quite an interesting one. Are they talking about carbon equivalents? Are they talking just about CO2? What are they talking about? Okay, so one of the key things up front is global warming potential, and this was a way that they try to balance out the different effects of the different gases on the warming of the planet. And the Paris Agreement is all about stopping warming, and by limiting emissions is a way of reaching that goal. So warming is the key, as you'd be all aware. But the thing to think of, in the carbon accounts worldwide at the moment, 1 tonne of carbon dioxide is equal to 1 tonne of carbon dioxide. 1 tonne of methane, CH4, is equal to 28 tonnes of CO2. They put a little E on the end. That's to show that it's an equivalent. So 28 tonnes of CO2e is 1 tonne of methane. And nitrous oxide, the big nasty, is 265 tonnes of CO2e. So for every tonne of nitrous oxide that's emitted, it's calculated as being the equivalent of 265 tonnes of CO2. So it's a way of balancing out the warming potential of those different gases. The other thing to remember with these do change, and they do review them, and there have been changes over time as they've got better and better knowledge. So you might be reading an old paper from 2004, which gives some figures around emissions, but you have to remember that they may not be using these same numbers. So it's very hard to compare apples with oranges, even if it looks like it's the same sorts of calculations. So that's one thing to keep in your mind, and I won't go into today because this is what's the GWP for the global warming potential for methane is. You'll often see a little 100 next to it, and that's what it's calculated to be over 100 years, because methane is a gas that is very warming, but it starts degrading quite quickly and degrades in the atmosphere after 10 to 12 years. So what they've done is divided it up and spread it out over 100 years to make it equivalent. CO2 is there for 1,000 years. So, but you might see some talk about GWP star, which is another way of measuring methane. But at this stage we're sticking with methane being 28 times, and it's the GWP 100. There's sort of probably 3 main categories about how people account for greenhouse gases, and it depends on what they wanted to do. The first one, and I'll talk about these in a sec. I'll talk about the national and state emissions in a sec, and they're quite specific on how they report things. Then a life cycle assessment or a carbon footprint. Some of you will have seen these, and this is like you can do a carbon footprint on your cup of coffee. So it's the whole thing, and it's usually presented in emissions intensity, so how much CO2e per kilo of product. And then we have business accounts, or if we're talking from farms, so it's a farm account, so a business account. How many what emissions coming from that business? So that's the other thing. And then you'll also see this scope 1, 2 and 3, just always good to keep in your mind. So scope 1 is everything that occurs on site. So if you're on a farm, that's everything that's on that farm. That's what the calculation takes into account. Scope 2 is electricity emissions, and if you're doing your own farm account, you need to look at those. So it's electricity being generated at Muja, but you're using the value of it on your farm. So that's a scope 2. Scope 3 is all the emissions associated with the purchased inputs. So it might be fertilisers, it might be, if you're a business, it might be the cups you buy to serve your coffee with or whatever. But, so how are we doing? This is WA's greenhouse gas emissions as reported in the National Greenhouse Gas Inventory. And you can Google that and you'll be able to get all the reports, and you can divvy it up by state, all those sorts of things. But I've just grabbed WA's here. From 1990 to 2020 or 2019. WA is the only state whose emissions are going up, by the way. Nationally, Australia's emissions are slightly decreasing, but that's because other states are decreasing to take up WA's slack. More than Queensland. And you can see the yellow bars are where the big stuff's coming from. Energy, 92% of the state's emissions. That's stationary energy, electricity. It's energy for transport. It's fugitive emissions, which is a growing thing in our state budget that comes from oil and gas. There are quite a few emissions in there. The other interesting one, if you have a look at agriculture, that's this green line here, and it's fairly steady over that time. Land use change, and that includes really forests and grasslands and things like that. As you can see, and this was mainly related to land clearing. Salt land lost due to salt land, and quite a few plantations, and basically not much clearing. You can see it's become a net sink. It's below the line. So I just want to focus in on agriculture for the moment, because agriculture gets a pretty bad rap out there. Agriculture is causing all these emissions. This 11% here. And that tells another story. So these are the 6 categories that matter in WA. We've got the yellow, enteric fermentation. That's methane from ruminants, cattle, sheep, and a few goats. Methane being burped, not farted. Well, mainly burped. So that's the big hitter. The orange is manure management, so that's manure from those animals, but also piggeries, dairies, a few other bits and pieces like that. Agricultural soils, so that takes into account all the cropping emissions, but also most of the pasture emissions as well. Field burning of agricultural residues, not so much happening these days. Liming gets its own little category because it emits CO2 as it's been applied. It's the CO2 captured in the lime is released, and urea application is also given its own little category. So see why people talk about livestock. But here's the cropping ones. I thought I'd give you this. So crops in WA, and what I've put against the crop emissions are all those agricultural urea and lime. There's probably a bit of a flex in there, but as you can see, the state yield goes up and down seasons. but generally increasing. Along with it go the total crop emissions. And there's a little bit of a nitrogen fertiliser story in here, which we won't go into. Mainly because we haven't got time. Livestock, you'll see from here, we've got sheep methane, it's been dropping, cattle methane. The total emissions from livestock is decreasing, and it really follows the sheep population. Decline the sheep population, less sheep, less emissions captured in the inventory for agriculture. I just put the value of the industry against there. Now, land use change, which was that other one that was going below the line. This is quite an interesting area, and there are lots of different categories. So there's emissions with land to forest that get converted to forest, and you can see that's a net sink. It's below the line. So as things get planted to forest or forest land increases, you get a sink in carbon. And the others are sort of moving around like that. But there's some quite interesting ones. There's land converted to cropland, land converted to grassland, forest remaining forest, cropland remaining cropland, and grassland remaining grassland. So there's some really confusing categories in there. Cropland remaining cropland, that's to do with fertiliser application, tillage techniques, species selection, and it's all done by collecting data nationally from both ABARES statistics and satellite imagery, all those sorts of things. A lot of the forest remaining forest, often that's about fires, things like that. Forest burns, it releases a lot of carbon. But when farmers are talking about reducing their emissions on farm, one of the levers they can pull is they can do some tree planting, they can change their tillage practices, they can increase their soil carbon, they can do all these things. That's all in land use change. It's not captured in agriculture. So the state reports agricultural emissions in that very narrow field, and it does nationally as well. So all the work that's happening on farm doesn't actually reduce agriculture's emissions. It's captured in here, which is quite interesting because it's quite a different story.
Sorry, just in the figures, but in physical reality, you're saying it's just unknown.
Well, no, when it gets reported nationally, it looks like agriculture's just continuing to power along and not doing anything, yeah. But actually, land managers are doing an awful lot, but it's coming up in here. So, for example, in land converted to forest, and we assume, we're still trying to get the data out of the feds, is that most of that is on private agricultural or pastoral land. And it's a net sink, minus 7,000. And these are sort of the categories. So you can see there's a whole lot in there that happens on the private land estate that contributes to land managers doing a good job. And when you look at the net emissions these are from the agriculture section of the national inventory, about 9,800. This is from the land use change on private land. We estimate it's about that. So there's actually quite a different story than what you hear on a lot of the news feeds or in the headlines about where the effort's happening. But it is about who's asking the question, and that's the hard part. I'll quickly just describe a life cycle assessment for those people who haven't because sometimes you do see those figures, which can be quite different to the national and state inventory. So this is done at a business level or a product level. And it's not just carbon. There's about 4 different factors you can do life cycle assessments of, and often it's water and carbon. But there's land use change, there's employment and society and various other factors, so they can do a full one. But usually you see them with carbon or carbon and water impacts. And it's about product intensity. So how many kilograms of CO2 equivalents per kilo of product that's done. And you can start at different places. So sometimes people will look at just the pre-farm gate emissions or the pre-business part. If we do something differently, what's going to make a difference on the life cycle of the product? Go right through to clothing. So there was a new one that came out from the EU which looked at comparing the life cycle product intensity of a woolen jacket to a synthetic shirt to cotton, things like that, and it was all about number of wears per thing, as well as what it took to produce that, whether it biodegrades, what sort of water. So there's a whole range, right? And thought I'd just share this one with you. For example, this was one that was done by Edie a little while ago, but they were looking at using carbon footprint to say, okay, bread in the supermarket, where are the emissions coming from? So you can see bread baking's a big one, so you might go, well, that's a pretty big lever, I can pull that lever. If we can use renewables to do the bread baking, we can reduce the impact. Kilo beef on the shelf, it's limited, there are limited levers there. It's just about all on farm. These figures are a bit older. I reckon this is probably should be more like about 5 to 10%. The interesting thing was they compared these food products, and I use the word food because that's what they did, and that so if you have bread and meaty bites, you're probably going to be using less greenhouse gases than others. But these ones are probably a little bit less now because this was an old study, but it was just interesting to see that range, and that sort of drives a lot of that conversation about eat less meat, add more vegetables. Katanning Research Facility at DPIRD, we did our own carbon account there, and we have a target of going carbon neutral by 2030. So we're underway with that. So there's some results there. There's more information on our website if people want to read through everything there. We also did our emissions intensity, but, the life cycle, but that was just for on farm. And so you can see the difference here. So for every kilo of lamb, there's 9.9 kilos of CO2 equivalent release. But like for the lupins, for example, for every kilo of lupins, it's only 480 grams of CO2 equivalent. So there's quite a big difference. And I won't go through this because I think Simon's going to talk a bit more about it. Asparagopsis, everyone's talking about it. There's some leases down here that they're looking to grow Asparagopsis, red algae. Phenomenal results in cattle and sheep as well. Cattle, over 12 months, if they are fed a small proportion of Asparagopsis in their diet for the year, 98% reduction in methane emissions, plus 10 to 15% increase in productivity. If people are looking for silver bullets, this could actually be the silver bullet.
Does it taste good?
Well, luckily they don't have to eat too much of it, but the way they found out about it was that sheep were eating it on the beach.
Oh, okay.
But it has delivery issues. How do we get it into the animals? We have issues growing it. As soon as it spawns, it dies, so you've got to reseed it from the wild at this stage. So there's a lot of money around the world happening at the moment. And just thought I'd leave you to that point there. It's about what they eat. Thank you.